This is a lesson on figuring out what completing a square actually means. And we will begin with expanding this expression somewhere on the side piece of paper. Please pause the video to do that. Okay, now that you completed your little task, let's compare your notes. I hope you remember that squaring something means that first you need to find out what the base of that exponent is. And the base is the entire expression binomial, which means that that binomial is supposed to be multiplied by itself, and we are not supposed to skip this step. As a result, then, you will continue with multiplying x by every term inside the parentheses, and then you will reiterate the same process with multiplying 3 by every term inside the following parentheses. As a result, our first term will be a product of x's, then a product of x and the 3, and 3 and the x, and 3 and the 3. Simplifying this expression will give us a new one, x squared, 2 times 3x, as we can see in the previous statement, and 3 to the second power. I purposely wrote these two terms in this form so we can observe the following. Notice that first term would be in the second power. Second term will have x in the first power. And last term will have an x to power 0, which made it a 1, which in return made it invisible. Our objective will be to be able to identify in our following examples the third term and what that number should be when squared to give us the third term of the final expression. Identifying what number multiplied by 2 in the second term is always going to be important, and realizing that you can do or should do these operations when your polynomial is arranged in standard form from highest exponent to the lowest is also very important to notice. I'm going to ask you to transfer this experience into a more abstract example. So on the same piece of paper, please show how you would simplify the expression a plus b squared. Please pause the video. So, if you remembered that squaring an item means clearly identifying the base of that item, then you probably multiplied binomial AB by itself twice and broke it down by distributive property, indicating every product patiently, writing it all out. Then you probably noticed that the middle term is the same thing, although it looks different, thanks to the commutative property of multiplication. Now we can write it as simply 2 times the product of A and B. So the final, simplest form of this expanded version of your expression should look like this. This example actually is a demonstration of what completing the square means. You see, normally you will have a quadratic equation in this form that you observe on the right side. And if you are able to identify certain things, such as which number is in the end and is not multiplied by x, and which numbers are in the middle and have only x to the first power, and how can I break this number in the middle to reveal the 2 and something else multiplied by it. In that case, you will be able to fold that information into an expression in binomial. Some number a and b squared, add it. That is an expression that we call a square of the sum. In other words, you recognized how trinomial could be folded into a shorter, simpler looking expression, square of the sum. So now let's practice. I took a trinomial and partially broke it down into pieces to help you realize what you should be paying attention to. So I have k squared plus 2k times 5. Now I'm asking you what should be the third term, and then in the end what should be the binomial, who is the sum. Well, the first thing that I'm observing is that in my original example right here, binomial had all pluses. And it came from a plus in the binomial. So now that I am noticing my example has all pluses, it is safe to assume that when I fold it, it will be a sum squared. Next thing I am observing is that I'm given the middle term and it's broken down into the 2 that I always need to identify, some number multiplied by some other number. And I recognize that that number, k, is actually the one that is the first term squared. It is the same number that would be the first term in my folded square of a sum. So this numeral, unknown in my case, goes into my square of the sum. Going back to the original abstract example, I realize that b squared, my third term, is actually one of the 3 items multiplied in the middle term. I recognized already who k was and where it goes. I recognized why the 2 is there. That is because of these 2 terms, which means whatever is left, the 5, is actually this third number, b, who is supposed to be right here, squared. And of course, I know that it will be just a 25. So I'm going to write 25, indicating that 5 itself goes inside of my parentheses. I always can check myself by simply multiplying this binomial by itself twice, expanding it, simplifying it, and verifying that my final result will look exactly like what the original was. Let's take another example. This time it's not as straightforward, but I am noticing that there will be 1, 2, 3 terms. I need to find who the third term was and which items then will go into my binomial. I'm also agreeing that binomial should be the sum squared, because in the trinomial all items are added. So, using the experience from my first example, I realize that I can find my third term squared from my middle term. And I wish I could see all 3 items multiplied in my middle term. Right now I only see 2. Well, that's actually not that bad because I know one of those items is that term in the front. So I now just have to figure out which number multiplied by hidden 2 gives me 14. And that's fairly easy because we know that would be 2 multiplied by 7. So I'm going to write that fact down. It was hiding in my 14 once again. 14 divided by 2 is the 7. So this means that 7 is that third number that I'm looking for my third term, who will be squared, just like in the example, original example. So I now will be able to fold it into my square of the sum. First number would be one of the 3 items in the middle. It would be the variable, the one that is in the front, squared, so n, plus it's the third item that was hidden in the numeral, which I revealed by dividing by 2. It is the item that I will square as the third term, just like in these examples, and we'll write it as a 7. I now can replace this with a 49, and to check my example, I will be able to simply expand this expression and confirm that I will receive trinomial that was given. You should have this example written in your notebook for future reference.